Malaysian students are from third year ECE, yeah? Third year triple.
Triple, ma'am. Third year triple and final year triple, and a few second years also we have gathered as an introduction.
Okay.
So Dr. Selvajyoti ma'am, Dr. Selvajyoti K received her BTech degree in Electrical and Electronics Engineering from University of Kerala, Thiruvananthapuram in 1995, and did her ME in Power Electronics and Industrial Drives from Satyabama Institute of Science and Technology in the year 2004, and did her PhD in IIT Madras in the year 2009. Now she is faculty in the Department of ECE, Indian Institute of Information Technology, Design and Manufacturing, Chennai. So she has 20 years teaching experience and 17 years research experience. She is a life member of IST and a member in various professional bodies, IIS, IEEE, SAE India, and ESSI. She has co-authored 4 books, 17 journals, and 19 conference publications. She was a co-chair of a School of Computer Science and Electrical Engineering Department from the year June 2017 to Jan 2018, and also HOD of EC department from Jan 2018 to June 2019. She has handled numerous positions such as UG admission coordinator and placement coordinator, PG admission in charge, also PhD admission in charge, many invited lectures, professional in charge, and she is a member of many disciplinary committees. Her research interests include power electronics, harmonics distortion, PNL, grid inverted, grid connected inverters, power quality, electric vehicles, medical instrumentation, and product design. So she received research fellowship in the University of Padova, Italy in the year 2009. Also received Best Paper Award in Technical Session 1.1 of CIEC 2016. Also, she is an active reviewer of various reputed journals. Ma'am, we are very happy to welcome you here for this session. I'll
Thank you, Emily.
hand over.
Thank you, Emily, for this. Yeah, sure. Thank you for a nice introduction. Yeah, I'm not okay. So here in this hall, I think the major crowd is female crowd.
No, boys are also there, ma'am. But
boys are towards the last. You ask them to sit not in front of the camera. Okay. So, okay. So let me share my screen. You have changed the host option to me.
One second, ma'am. I'll give.
Malishri, click on participants. Click on participants.
Screen share option. Now please share your screen, ma'am. Are you able to share your screen? Because we give multiple screen sharing option.
Okay.
Yes, ma'am, your screen is shared. But your voice is not audible, ma'am. Ma'am, you are in mute.
Yeah, thank you. Yeah, good evening. I think it's good afternoon all. I'm not able to see the students. Yeah. So good afternoon all. What is the duration of the talk? Inform to you. Students will I'm asking to students. How many hours you will be able to listen to the discussions? When of you please answer. How many hours is your patient's time? Hello.
1 hour.
1 hour. Your time you are telling or students' time. Okay. So let us see. I'm not getting into a full-fledged technical session. It's an overview sort of thing only. So I'm not sure you people are much aware of the what all are the work or what is that EV ecosystem. Electric vehicle ecosystem is all about, and what all are the components which is going in there, and where all the work of our engineers will be there. So this is what we would like to see here in this particular session. And I hope you all, as you are just going to be graduated or it is like they just third-year students or whoever be, you need to be in constant touch with the technical evolution which is happening every day. Okay, so it's like how your mobile phones you will be looking into, what all are the features you need for your mobile phone. Okay, my mobile phone, how many times you will be changing your mobile phones, no, right? So for that, what effort you may be putting? Once you lose your mobile phone, or once your mobile phone is not workable, or a new feature is coming into your into the market, you will have a feeling that, okay, I should also buy it and I should also want to have that. Okay. So the similar way only. So it's something like every day you need to be, that means you are in touch with what mobile phones market, right? So similar way, what all are the markets which are needed for the society, to that market also you need to be very much interactive and very much getting through. So that's what I want to convey there. So here, I think I'm not able to move the screen. Yeah. So now here as content of this part, I would like to say about this adoption curve. Okay. So based on the how we are getting adopted to EV and how that growth is happening year over year, growth of the EV technology, how it is happening. And then why people are interested in moving towards EV, and what is that ecosystem all about, and what all are its impact onto our grid or the distribution system. Because when we are developing this EV ecosystem, definitely we need to charge the EV batteries, right? So when we are trying to charge these batteries, this also to be coming from a renewable energy that again goes into a microgrid only, or to our own grid. So grid or microgrid only. So ultimately that is going to give some impact onto that grid system. So that part also little bit will be touching there. Then what all are the types of electric vehicles and what is the subsystems in the EVs, and the main contributor or main parts of the EV, which is the batteries. Batteries require the charging infrastructure. Then we require the electric motors as the propulsion system for the electric vehicle. So with this, these many things I would like to give an overview on all these items. We are not getting into very in-depth understanding of this, just an awareness on top only. So what all are the challenges which a control engineer or an electrical engineer need to consider, or when you are going to take your projects, okay, final year projects or anything like that, you can take one of these issues as challenge, and then you can work on that to contribute for the EV society. So now adoption curve, any product, once actually the product development is a good art, we can say it as an artistical way. That is how, what all are the things which is coming here is like design is the main aspect when we look into any product. Designing, and then first level of product development is towards the development of a proof of concept. Okay. So what is this proof of concept? Ultimately, when you look into is like developing the workable product. We are making a workable product there. So this workable product development will be taking a series of cycles it will be undergoing. So first level, it's like, for example, if you consider a fan, consider a electric fan or a ceiling fan, if you consider, in the beginning era, it is made of DC motors. So with the DC motor, how this could be, that is motor principle, all of you know that. And so the structurally, the motor, in the case of fan, the motor is outside, the rotor part is outside and the stator part is fixed there, which is on the ceiling of the ceiling. So on the ceiling, a shaft is coming and the stator is stationary there, and the rotor part is moving where it is spinning of the leaves is happening there. So right, so it's like in the beginning and all, we are not bothered about the appearance of the fan, how it is looking. Just the operational effect of the fan only was taken into account, and the fan was operating effectively. Then later stage, once the proof of concept is any issue there? Hello, am I audible? Hope I am audible. Hello, Amaleshwari. Amaleshwari, could you ask others to be sitting, all the teachers be sitting there?
Yes, ma'am, it is audible.
It's audible, fine. I'm feeling it difficult when teachers are standing and then, okay. No need, they can sit over there. The students will listen. Okay, so they won't make any noise and all. They will keep quiet or they will listen to me. Okay.
Okay.
So please ask them to sit. Roaming around will be disturbing, and even the students' attention also losing.
Okay, ma'am. Okay, sure, ma'am.
Yeah, please cooperate with me. Okay. Okay, so now as of here, as the example which I told, the initial region, the product will come with a proof of concept only, how this fan will be, the motor is used for the application like fan. Okay, so then later stage, the complete perfection of the technology will come in various stages and steps only. And by then the innovations, new innovations will happen in the motor side, and then now we are using brushless DC motors replaced with those DC motors. So similar way, the evolution of the things are happening. And so this, how many iterations in the technology refinement it might have come, that you can imagine. Okay, as EEE engineers, you will be able to feel how many iterations they might have gone through to develop this product. And once the technology is coming to a better pace, then only the art will involve there. So artistical way of designing will be coming in picture hereafter, and then the fan of various features with various features, and they tried a lot of options there. And then based on that, they will conclude that without affecting the efficiency of operation and the purpose not lost, it should be effectively utilized. So that's the aspect which is coming there. So similar way, what I would like to say over here is that we are living in a dynamic economy, and here constantly evolving with changes in the emerging markets, as I talked about the mobile phones, fans, and these examples. And also new technologies are evolving, the fan or the motor, what all are the evolutions happening. So accordingly, the technologies are getting changed. And many government policies are marked on the sustainability, and then our own preferences, how the consumer preferences are getting changed. All these aspects decides the adoption towards a product. So the product adoption will be once from the beginning, you could see here that the S curve. So the year-over-year growth you could see it as the growth will be in the beginning a substantial growth you could see on the development side, on the technology side, but the adoption will be, because we need to work out a lot on the development of the technology or proof of concept. So you can see that the adoption, nobody will be adopting in the beginning years, but as the years goes, the technology will be coming to the technology part, that will be coming to a better pace of it. You will be able to see here it's getting saturated. As years increases, you can see that year growth, that's going to be minimized, or it's coming to a saturation. So once it's completely perfect, that time you can see that the adoption is also complete. So this is how the adoption is going to happen. And as per Federation of Automobile Dealers Association, regarding the sales, EV sales, that has been shown 155% year-over-year growth between the fiscal year 20 and 22, with a units of these many unit sales, 4,29,217 units in the fiscal year 2022. This is about India I'm talking about. So global way, when you look at global market also, it's keep on increasing only. Adoption towards EV is keep on increasing only here. And here we have classified electric vehicle, that is green colored is shown as the battery based pure battery electric vehicle, and this plug-in electric vehicle, that is hybrid, plug-in hybrid electric vehicles, is shown using blue color. So anyway, the sales rate is getting increased here, and all this, even with this pandemic situation, there is due to the rapid pace of the innovation in the technology, this is getting the adoption is very quick. You could see here for towards the EV, though it started along before this EV with the DC machine started very long back, even before IC engines, but the revolution in IC engines, which has happened very quickly, and now at this moment we can say that they are perfect right now. But now the technology, that is innovations in the power electronics, all those aspects have made the technology development and miniaturization, artificial intelligence, data-based, digital technology, all these have paved a great way for this EV adoption or the EV technology. So here you can see here that in this top slide, what is the percentage of different categories of vehicle different categories of vehicle adopted in India. So what is the sales rate for two-wheeler, three-wheeler, four-wheeler, truck and all electric based, you can see. So the two-wheeler sector is more, right? 67.27%, and three-wheeler it's around 3.17%. Yeah, no, passenger it is 25. Next level is this one, then this one, okay, and e-bus and all very less only in our country. Adoption rate in our country is very less. So this is about the sales figures only. What all are who all are the market leaders, to show that only. So Tata Motors stands top there. MG four-wheeler, okay. Tata Motors, MG Motor, and other categories you could see here. And they based on the state-wise data also you can see here. So Uttar Pradesh is standing top there, okay. Then Karnataka, Maharashtra, Gujarat, and then Tamil Nadu. This is the statistics we are seeing here. So this is the thing, and for two-wheeler market, Ola Electric is in the top leader. Now 2022 data I have shown here. So based on this, now why, as I mentioned, government initiatives have been helped a lot for the improvement in this EV adoption, and this has been started with the Paris Climate Agreement, where all the nations have came together and then decided with an emissions objective for 2050. So where every country has oath that we will reduce the carbon emissions as quick as possible. So when in India, in our country, what the government has taken some moves or steps towards minimizing or eliminating or the carbon emissions. So for that, the DST, Department of Science and Technology, had engaged with Electric Mobility Program from 2000 since the year 2012, and they participated in the development of NEMMP 2020, that is National Electric Mobility Mission Plan, which is this policy was announced in January 2013. And this has helped towards formation of FAME-1, which is faster adoption and manufacturing of hybrid and electric vehicle schemes, launched in 2015. Okay, so a pilot effort implemented, some recommendations was made through the joint technological platform, that is TPM. Okay, so all these are ultimately towards reducing the carbon dioxide emission only. So by 2030, we would be able to achieve 100% electric mobility. That is the target. So that's why the huge growth you are seeing in the EV technology. So here it's like 870, because now it's running on IC engines or fossil fuels. So fossil fuel will be causing a lot of carbon dioxide emissions. By implementing that is this full-scale paradigm shift of EV, will shift towards EV by 2030, can save around 876 million metric tons of oil equivalent worth rupees 20 lakh crore, and a crore and a gigaton of carbon dioxide emissions. This is what the data shows. Okay, so we are so this is the step which is taken by the government of India. So why we are interested in EVs? So electric vehicles, the main objective is that Paris Climate Agreement. Why it has happened, why we are also part of that, is because we know our capital city, Delhi, which capital state, Delhi, which is coming as the most polluted cities, world's most polluted city today. And so And other places also it could be seen here as per 2022 data. Mumbai is there, then Calcutta is there among these numbers. Okay, so air quality is getting deteriorated because of the pollution, and this is specifically because of the transport sector, and you could see that 39.3% of the transport sector, among other places also it's there. Other ways also this contamination is happening, but this is the largest sector we need to sort out. So that's why this EV, electric vehicle adoption is coming here. So now, based on the European Environmental Agency report also, that also says that transport is causing the major aspect you are seeing there. So based on that, so this is the second why we are EV, because that pollution is the major concern here. And another thing is, like, we know that the petrol cost or diesel cost, it's hiking like anything. So that is, so fossil fuel need to be, the use of fossil fuel need to be used, or we need to eliminate that. So for that, some option we need to, that's why it's going there. So then next important aspect is that reliability of this vehicle. So when we consider the IC engine there in this, so that will be like, in case if anything goes off, then it will stop its functioning perfectly. So now it's like, friendly technology is so much advanced, and it is able to have the vibration effects and all. So many research has been come, and it is in a bit nowadays. But even then, because of that many moving parts, these moving parts can be eliminated if we are going to use our electric motors for the propulsion part. So then next we are looking into the efficiency aspect of the motor. So as I mentioned, the vibration effect, our electric motors will be able to give, we are able to design greater efficiency electric motors, and that helps a lot in the adoption to EV. And then controlling of these motors through power electronic converters, that also another aspect which is coming in the improved efficiency achievement is. So hope any you can have the questions towards the end, or you want to have the questions in between also, you can. What do you want? You can note down the questions and towards the end, otherwise it will be time consuming, I think so, right? Amaleshwari, can you make this mic unmuted? Please make this mic unmuted so that if anybody could answer me back, they will be able to answer back. Amaleshwari?
Yes, ma'am.
Okay. Let it be unmuted so that I could hear what is happening there. Okay, fine. Next is electric mobility ecosystem. So here you can see here this ecosystem is, so the power generation is the, so when EV is concerned, you require the charging stations. You require the charge points or the charging stations. Charge points or the charging stations are required. They can be AC charging or DC charging. And the service providers and some regulatory authorities are needed. Charge point operators and e-mobility service providers, they are part of it. And all these charging points or charging stations, they need to get their power from microgrid or our grid. So they are also energy generation and distribution system and transmission system operators all are coming in place. And this is then they need to formulate a compliance and regulating policies to evolve the proper operating of this ecosystem. So this is the main ecosystem. So in all these areas, we have a task there. Okay, in all these areas, we have in the ecosystem, every area we have our own task over there. So here, first task, which is on to, as I mentioned, the distribution system and transmission systems. How, when it is connected, this electric vehicle charging stations are connected onto this distribution systems or the grid. That's going to affect the performance of the system. So we need to place the charging stations at optimal locations to minimize the losses. We can think about it as this is some research work which is done on optimal placement of EVCS. So electric vehicle charging stations or electric vehicle service equipment. So here we have considered one grid, electrical grid, and then based on the electrical grid, we are keeping these electric vehicle charging stations using optimization techniques. Using optimization techniques, you will be able to keep these charging stations at optimal distance so as to minimize the losses, minimize the overall losses in the system. So when you look into this, we need to consider the charging behavior of the electric vehicle. It won't be like a constant load which is added into your load. It will have a different scenarios you need to think about here. That is, one is there will be at the time of starting, it is going to draw a then you will be gradually reducing the current so that the voltage is there, so the power is constant during that time. So it's having a constant current mode, constant power mode, and then while disconnecting, once it is near to the level what is needed, then it is after 80%, it will be something like a saturated way only it will be going. So we need to disconnect the battery by reducing the current to zero, and reducing the current to zero, then only it could be disconnected. So once the current goes to a minimal value, then we will be disconnecting it. So we need to model this load as a constant load, constant current load, constant power load, and then that way we need to model it. So then this effect of this onto the system is studied, and we can see that the losses, in order to minimize the losses, the optimization technique like particle swarm optimization is used here. So ultimately what I want to say is this here, one good problem is here when it is connected to the transmission system and distribution system, how we will be able to locate the electric vehicle charging stations. Even you can model the distribution system, considering the effect of harmonics also, the load flow diagram. load flow analysis, or that could be designed with the harmonics considered and then studied about that. This is one open problem. You could even you will get good publications also out of it. So then next is about the other components which is coming in the electric vehicle. So why we are going for electrification? So IC engines, as I told, well proven technology as of now, and now we can't as a whole, you may not be able to throw away the complete setup and then directly jump into this battery system. Okay. So that's why for increasing, with considering the increased efficiency of the machine, increased efficiency of the system, as I mentioned, the technology advancement won't happen all on a sudden to a jump. Okay. Higher jumps may not be possible. So what we do gradually, we are moving with reducing this engine capacity, a little bit addition of battery, So we keep on reducing the IC engine part capacity, keep on increasing the battery part, so that all at a particular stage, what will happen is the IC engine can be completely eliminated and fully electric vehicle is possible. So this is what the all electric vehicle is attained through this evolution only. So it's like from the IC engine, all on a sudden, because it's a well proven and it's working perfectly. So we need to add some battery into the system. So that's why just for starting and stopping alone, we used battery initially. Then we utilize while braking. Let us try with a regenerative part there. Okay. So then keep on reducing. This is how it started. Okay. So then later it's moved to a greater thing. So you can see here, first microhybrid. Hybridization is the percentage of what percentage of battery is added into the system. Okay. So here it is like automatically start and stop of the engine with the battery. So whenever in traffic, we need not waste our fuel. So we just switch off and switch on the vehicle and the battery part is utilized for that. Then next, mild hybrid, where you have a regenerative braking, as whenever the brake is put, some amount of energy could be fed back to the battery which is utilized for the other start and stop activity. So that is what mild hybrid means. Then full hybrid, you can drive the machine, can drive the vehicle at times only with electric motor. Plug-in hybrid, where the rechargeable batteries are utilized there. Okay. So this is what I think. Up to this, it's clear to you. Hope it's all understood up to this. Yes.
Yes, ma'am, we can continue.
Okay. So now what is happening by hybridization is that you have a stop standby micro hybrid. As I mentioned, this portion, this could be saved. And by mild hybrid, the braking part, the energy could be driven back to the batteries. So storage is possible. And so full hybrid, the engine losses, the efficiency of engine is very, very poor. So the losses in the engine could be avoided, so that complete by using this full hybrid or using plug-in hybrid can eliminate the engine entirely. And so the efficiency of the system could be improved a lot with the all electric vehicles. So now this is about the classification of EVs. So there are, as I mentioned, the hybridization. All electric means it's with batteries. So I'm not going to talk about fully. All electric means it's with battery only, and hybrid means a combination of other stuffs will be coming like fuel cells, flywheels, ultra capacitors. These are the combo which is coming. So anyway, in all the cases, you require the battery part. Battery part is needed there. Battery part is needed there. So depending upon the propulsion devices, this is how the classification is there. Okay. So, so now the hybridization using supercapacitors, because the battery, just have an idea. So battery, you know that the charging time or discharging time required for a battery is very much larger, very much larger. You can see this slide. See this portion, it will take longer time. Whereas a supercapacitor, the manufacturing or the materials used to supercapacitor is such a way that it can be charged or discharged very quickly. So by combining the effect of these two, batteries and supercapacitors, we can get both high energy density as well as power density, and this will be able to increase the operation time of the system. We will be able to protect batteries also and increase lifetime possible, and the sizing also, optimal sizing of stack also will be possible. And one more aspect is that thermal enhancement is possible. Thermal enhancement, that is thermal aspects also we can increase, we can address it very quickly, because what I am telling is when you want to use the battery for EV driving aspect, whenever the accelerating mode or an overtaking, where the overtaking mode is coming, or you are going in a uphill movement, a gradient way when you move. So when you are moving on a gradient path, or you are trying to overtake another vehicle, so in these cases, you may require, you have to accelerate the vehicle. So in such cases, you will be seeing that, if your vehicle is with a battery alone, so the battery pack design need to be for that peak requirement, which is going to be used for a shorter duration only. Maybe it will be over a millisecond duration or something like that, or it will be within seconds duration only. This is going to happen. Very shorter duration only you may require this. But for that, you need to design your battery pack with a high capacity. So to address that issue only, the supercapacitor. So during these periods, if we are using supercapacitors, then the capacity or the weight of the vehicle can be reduced so that the performance of the vehicle can be increased, and the battery's life also we will be able to improve in that way. Hope you understood. So this is like flywheel based. This is a startup which is in Germany, Stornetic. They have utilized this flywheel, Pentadiene flywheel. This is flywheel is like made of a very lightweight flywheel. It's made of carbon fiber, and attached to this flywheel there is a motor generator, rotor is there. So through that they will be extracting the energy, kinetic energy of the flywheel, and that is utilized for a charging station, which is a fast charging station or a DC charging station. This has been used. Okay, so I hope. So this is about the EV subsystem. So EV subsystem is having electric propulsion system. EV, that is where our motor is coming, our motor, power converters, vehicle controller. This is how the motor power is transmitted through the transmission, mechanical transmission to the wheels. So in order to activate this propulsion system, we require the batteries. Okay, batteries, and there is batteries are like lithium ion batteries. Many varieties of batteries are there. So these batteries will come as the power source, energy source for the system. And for other auxiliary purpose like our air conditioning, then other power windows, many things will be there. So all those parts can be addressed through another battery pack, which will be forming the auxiliary subsystem, or any other sources can be used for that this arrangement here. And then in the EV ecosystem, in addition to this, this is about the vehicle part only. So to charge these batteries, you require charging, which can be through conductive or inductive chargings, and then then there need to have some EV safety precautions, EV safety standards needed. Then the consumer needs also, and then another aspect is like the communication of this vehicle with other structures. So that is another one, vehicle to vehicle communication and vehicle to infrastructure communications is needed, and grid interface and communication also another thing which is coming. So when we discussed about that grid-based application, we talked about only the policy makers, or with respect to grid only we talked about that. But with respect to consumer also, location of the electric vehicle can be planned. So because once the electric vehicle charging stations can be planned, because once the charge is lost, if we know the charging stations locations,